Thanks for coming tonight. Thanks for sharing your Friday night with me. I'm visiting from Colorado and was able to be here for a Friday night. So thanks for coming. So I'm James Ward from TypeSafe. I've been working at TypeSafe for 1.5 years, and I'm a contributor to Play and Activator and a couple other projects there, and get to go around and teach developers about the platform. So tonight's going to be about Reactive all the way down. We're going to start with just, I don't know how much time we'll spend in slides, a couple minutes, not very long. And then I want to spend a lot of time just writing some code tonight and showing you some of the stuff and how it works. So feel free to stop me at any point and ask questions. We can try to make this as interactive. If you're not feeling interactive, there's some beer in the back. I got mine up front, so that'll make it more fun. And then we're going out afterwards for Alexi's birthday, right? So we'll find some place to go celebrate with Alexi. So thanks for spending your birthday with us. All right, I got to remember to start the video capture here. Go. Okay, we're going to try to do screen capture on Linux. It's a new experiment. It may go horribly wrong. We'll find out. Okay, so Reactive all the way down. What this is going to be about tonight is about building reactive applications that are reactive all the way from the back end to the UI. And so there's a bunch of different pieces that I'm going to go into. Some of this, if you guys have been doing reactive programming, it may be a little bit of review, but hopefully some of the Angular stuff will be new and interesting for you. And then I'll show some of the SBT-Web stuff that I talked about last night, a little bit of that. SBT-Web, as Alexi mentioned, is a new asset pipeline in Play 2.3. You can use it outside of Play, but it's a new way to write the client side of your application in a Play application. So if you want to learn more about kind of the ideas of Reactive, reactivemanifesto.org is really the best place to do that. There are some high-level ideas that you can walk through. What I'm going to focus on tonight is really the implementation of Reactive on the TypeSafe platform. So in the TypeSafe platform, how do you build reactive apps? And so I want to start out with async and non-blocking will be the first thing that we try to tackle. And we're going to start with that just on the website, on the server, and then get to the Angular side. So I'm going to start out with writing a controller, and I first need a new application. So we have a tool called Activator. It's a way to create new apps and run them. If you're familiar with the platform, it is an SBT launcher with an optional UI. So you can use it from the command line. You can use it from a UI. Both. It's up to you. So I'm going to use it from the command line tonight. So I'm going to run Activator new and create a new application. Let's give this one a name. We'll call it Reactive all the way down. Sounds rat. I didn't know that this would start with rat, so that's fun. And then I'm going to select a template application. There's a bunch of templates to choose from in Activator. I'm going to use the Hello Play and then 2.3 Scala. So that's the app I'm going to start with here. And let's just run this thing. So I'm going to do Activator run. If you can't see the fonts well enough or anything, let me know, and I can bump those up or move windows around. So while that's getting up and running, I'm going to go open that up in IntelliJ. This is one of the nice new features in IntelliJ, is that I can just go to a project here in IntelliJ and open it up. I don't have to generate the project files. With the Scala plugin in IntelliJ, it now knows what an SBT project is and can just open an SBT project. So it'll take a second to resolve dependencies and pull all that project in, but let's see if we can go load this app that we're going to be working on here in the browser. So there's my app, and we'll start writing some code. So while this is loading up in IntelliJ, the way that Play works is we have a file that we define our routes in. And the routes is where we define the forward routing information so that when Play handles a web request, we tell it based on an HTTP verb and a path what controller is going to handle that request. So let me show you that file here in IntelliJ. So that's in the conf routes file. And so there's our routing definition for this application. I have a get handler for slash. When we make a get request to slash, that's going to be handled by controllers.application.index. And then I have a couple other controllers in here, routes in here, one for my static assets that I'm managing, and then one for the WebJar assets that we'll talk about a little bit later. So let's go take a look at when I was in my browser and made this request to localhost 9000, that was handled by the get slash route there. So that went to app controllers application.scala. So this is our standard controller here in a Play application. And so here we're extending controller. You don't have to do that. That just brings in some convenience methods. And then we have a function here, index. An action, all that an action really is a wrapper around a function that takes a request and returns a result. And the result is the HTTP response. The request is the HTTP request. So you can get the headers and set the headers on. You can get the headers on the request, set the headers on the result. So in this case, this controller, what it's doing is it has a function here. I'm not using the request, so I don't have to specify it. So now I'm just returning the result, and the result is OK, OK, status code 200. So I'm returning a status code 200 result, and the body of that result is this views.html.index, and then it's passing a string to that. So that's coming from down here in the views package. Play has a server-side templating language that's based in Scala. So if we open up this index.scala.html, we'll see here's our template. Takes a parameter, which is a string, and then we're using another template we're calling app main. Everything that Scala is prefixed with an @ sign, so we're calling the main template. And you'll see that this template has two parameters, a string and a content block of HTML. Here's our boilerplate page. And then we fill in those two parameters. Here's the first parameter that goes into the title. And then here is what goes into the body of the page. So that's how we get this page rendered when we make that request to slash. So some of the cool little features of Play are that we can make changes to all this stuff and just hit refresh in our browser. So if I make a change to in the routes file that doesn't work and hit refresh, then Play is going to tell me that there's a compiler compiling the routes. And likewise, if I make a change to the controllers, the templates, the client-side stuff, we'll see in a little bit, we're going to see those. So that's your quick little intro to Play. But now I want to dive into the reactive stuff. But any questions about the basics before I go on? Okay, so now let's start heading towards reactive. So one of the parts of reactive is to be async and non-blocking. Async, it's kind of strange to say async and non-blocking because you can't really be non-blocking without being async. You can be async and not be non-blocking. You can be async and blocking, but you can't be non-blocking without being async. So it's kind of weird to say both, but for some reason we do. And so what we're going to do is start heading down the path of creating a controller that's going to be async and non-blocking. And that's where we'll start to get into the reactive stuff. So, so let's go create first a new route here. I'm going to call it foo, and then this is going to go to a foo method. So let's define this method, foo, and I can just create an action and return a result, OK, status code 200. And now if I go to /foo, then we'll see there's my very exciting empty result, which is a status code 200. So this was a, there's nothing async, there's nothing explicitly async about this controller method. Because right now, I don't need to do anything asynchronously. Underneath the covers, Play is actually doing these controller method calls asynchronously. That's why we define them as functions, so that we can handle them asynchronously. So we put these requests into a queue and then execute those on the queue, or pull those off the queue and execute them as we can get threads available. So in this case, there's nothing async about this other than what's underneath the covers in Play. But if I want to be explicitly async, then what I can do is I can, instead of doing an action, I can do an action.async. And now, instead of taking a function that takes a request and returns a result, now I need to return a future of a result. So I'm going to return to Play not the thing, but a future of the thing. It's going to be something that will in the future produce that result rather than the actual result. And so the easy way to make this code work is to create a new future. So I can do a future.successful. Let's go import that Scala concurrent future. So future.successful. And now I'm creating a new future that's going to basically immediately fulfill with that same result. So now I'm explicitly async, and let's put something in the body so we can see a change here. So now when I hit refresh, there I see that now this thing is working just like it was before, but now it's explicitly async. It's still not non-blocking because there's nothing to not block on yet, but it is async. And so what that means is that instead of giving the thing back to play, I'm giving a handle to the thing back to play, and then when that thing produces a value, then the response will be sent back to the user. This is how play works under the covers for you, no matter how you write your controllers, but you don't have to write the extra boilerplate code if there's nothing to not block on, and thus no reason to be async. So questions about the async controller before we go on? Okay. All right, so now let's actually create something to not block on. The really easy thing to not block on is just a timeout, basically something that says, hey, call me back in some amount of time. So I'm going to create a new feature using the promise API. So I'm going to do a promise.timeout. And promise.timeout, what it takes is the thing that I want to produce, or the function that I want to call. And so I can now just say, OK. And let's put a string in there. And then the second parameter here is how long and a duration, how long I want to wait to actually trigger that. So let's do 5 seconds. And let's remove that. And we're going to have to import a few things here. So let's import now a Scala concurrent, or no, yeah, Scala concurrent duration underscore. That'll give us our seconds there. And then we'll see if we try to refresh in the browser that we actually get an error, because now we're actually doing something that's going to require a thread. And now that we're doing something that requires a thread, we need to tell this application where it's going to get its thread from. So now this is going to be operating on multiple threads. When we did future.successful, there actually wasn't a thread needed for that, so it didn't require us to have an execution context. But now that we are doing something that is going to operate on another thread, possibly another thread, could be the same thread, we don't know. But what's going to actually be on that thread is when that callback happens. So when that timeout triggers and we call that function, we need a thread to actually execute that thing on. And so that's why we need to tell it an execution context. An execution context is basically a thread pool. It's an abstraction in Scala over the thread pools. And so we need to tell this thing where it's going to get its execution context from. We could actually see where that was needed. If we look at the method definition for promise.timeout, you'll see that there's a second parameter set there that takes the execution context, which can be supplied through an implicit. And that's why the error message that I'm getting is that I don't have an implicit execution context, and so I can import one. And I want you all to take note of the actual error message there, scala.concurrent.execution context. Does anybody notice how that's different from how Scala used to be? This is using a newer version of Scala. I don't remember. I think it's 2.10.4 or something like that. Does anybody know what's different? This was my only contribution to Scala, and I'm really proud of it. So it used to just say import execution context.implicits.global. And now it actually gives you the fully qualified path to that global. It kind of assumed that you knew where that thing was before, and so now it gives you an error message that's actually useful. So that's my only contribution to Scala, 10 characters or so, but I'm really proud of an error message that actually is helpful. So thank you. Thanks, yeah. Felt good to get something into Scala and actually see it there in my demos. That's awesome. OK, so let's import that thing, and then let's hit refresh. And now it's going to compile. And then once it's done compiling, you'll see that it's waiting. So my browser is spinning for 5 seconds. If we open up inspect, we'll actually see that. So let's try it again. So we'll see it's waiting, waiting, waiting. The browser is spinning. And then after 5 seconds, it fulfills the request with the value. So we just did that now async and non-blocking. So now there's a request coming into this controller, and this controller immediately exits with a future of the result, and now there's no thread allocated to this request. So there is somewhere a thread that's keeping track of all the timeouts in the system. It's, there has to be a thread there to keep track of these. So there is some thread that's going to get reused for all the timeouts in the system. But all the requests that come into this controller, they are just going to make the request, then no thread. And we don't close the connection. The connection's still open. So this uses Java NIO under the covers to not have that thread per connection limit. And then when the future completes with this value, then we get a thread back for that connection and then can send the response back down to the browser. So now this is obviously a lot more efficient way to use your threads on your system. And so we're not just wasting threads when things are just sitting around waiting. So that's async and non-blocking. Questions about how that works? OK. All right, I guess we need more beer. Oh, there's a question. Great.
Yeah, so you mentioned using I/O and not to get around a 30 connection. Talk about 30 socket connection in the browser, right?
So on the browser side, the browser does have some limit in number of concurrent connections. This doesn't address that. This addresses the side on the server, where on the server, the typical Tomcat server has a thread pool of 250 connections, which means that if you have 250 threads available, you could only have 250 actual concurrent connections, whether those things are blocking, no matter what's going on. What is that? Yeah, so one of the reasons why why Tomcat only gives you a small number of threads is because there's a lot of context switching overhead as you increase your threads. There's also a lot of memory consumption associated with threads. I think the default stack size on the JVM is a meg, and so that means that for each thread it's a minimum of a meg. And so you really want to keep your threads as small as possible down to your number of cores. And that's the ideal. And so that's what we try to do, is try to make much more efficient use of the threads. The reason why Tomcat needs to allocate all 250 threads is because they don't have a way to do non-blocking. Newer servlet APIs do have a way, but the traditional servlet API is blocking. Yeah, garbage collection is another reason as well. Yeah, nice. Yeah.
I have a question. So let's say I want to do 2 outputs on this page with different timeouts. Is it possible? Is it easy to do with play? And what's involved?
Timeouts on how long it takes to fulfill that feature.
Yeah, in each string, I want to have a page where each component will be rendered by different functions, and they will appear as soon as they're ready.
Yep. And you explicitly want a timeout?
Let's say I want to do 2 timeouts, right? 2 strings, 2 timeouts.
OK. So the future doesn't have a built-in concept of a timeout. There's a few different ways to accomplish it. You can do it purely with futures, where you basically create 2 different futures. And then there's a way to say the first one that completes is the one that I'm going to use. And so you kind of aggregate a timeout future with your actual business logic future, and then you say, give me the result of whichever one of those completes first. So that's one way to do timeouts with futures. The other way is with Akka and actors. Actors have a built-in timeout mechanism that we'll get into in a little bit. Does that addresses just the timeout question? Was there another question that related to that?
The general question is, if you have 2 pieces of the page, in each of them is rendered by different functions, and I want, as soon as each is ready to show it. So what's a way to do this?
Yeah, so the easiest way to do this is with AJAX. You're going to make different AJAX requests, and then you're going to have those come back at probably different times. And then when they come back, you're going to trigger some JavaScript and then change the page with the data that you got back from the AJAX request. AJAX is the easiest. There is a different way to do it, which is what Facebook is using. It's called Big Pipes or something. There's a great presentation by Jim Brickman. LinkedIn is now starting to use this as well. And there's a great presentation from PingConf on exactly how to do that with Play. The challenge with that is that right now, if you look at this view is actually blocking. Until that whole template is ready, it's not going to return a string. And so Jim Brickman actually created a way to have templates based on futures, and then they can aggregate together other pieces of templates that are also based on futures. And then there's a way to do that that the page renders correctly. And so it's kind of a complex thing to do without Ajax. But when you need like SEO, or there's other reasons to do it, but SEO is one of the primary ones. Yeah, just search for PingConf videos. So PingConf was the Play conference in Europe somewhere back at the beginning of the year, and they recorded all the presentations. So yeah, just search for Jim Brinkman's video from PingConf. Yep. OK, other questions about our async and non-blocking code here? OK. All right, so that's great. We've got something async and non-blocking, but now we want to do something more interesting. Obviously, I hope you don't have promise.timeouts in your code. Not a whole lot of reason for them. So let's do something that's slightly more interesting. So now, instead of creating something non-blocking on a timeout, let's do it based on another web request that's going to go out to another service. So I'm going to create a new web request to jamesward.com, and I'm going to use Play's web service library to do this. So let's, I forgot one piece to this. New in Play 2.3, this is important for Play people. You now have to explicitly import the web service library. So you have to import playkeys.ws. I hope that's what it is. And then IntelliJ should refresh, and I'm going to have to restart Activator as well. So they actually factored out the web service client library in Play 2.3, so now we have to explicitly import that. And I should just have that in this default template since it's pretty commonly used. But once that finishes refreshing, then we'll be able to, not yet, make our web service client library request. There we go. OK. So import that. OK, so this is the web service client library in Play. And this is an async and non-blocking web service client library. So I'm going to set the URL. Let's just set it to, for simplicity for now, jamesward.com. And then I'm going to make a GET request to that URL. So this GET method here, it returns a future of a WS response. So it's giving me back something that I can read the web service response out of. And that's not the same thing that I need to give to Play, because Play needs a result. So the result is the side that I can write values into, and this WS response is the side that I can read values out of. And so there are two different APIs. So in order to fulfill this, make this action.async happy, I can't give it this future of WS response. I have to give it a future of a result. And so I need to now transform this future. So to transform, most of us Scala developers are probably familiar with it. Those newer to Scala, the map function is how we take the thing out of the box and turn it into something different. So I'm going to map on that future of WS response. So now in this map, I can actually work with the response and transform it. So let's take our response here, and now I'm going to produce the result that Play needs. So I'm going to produce a OK, and then let's just give it the response body. So I'm taking when the response comes back from jamesward.com, I'm going to transform that response into a result and give that back out. But what comes out of this map now is a future of S, and S is the result, which is what the function inside the map produces. So that's how I'm going to now give Play the future of result that it needs. Oh, and I need another implicit. This one is also fully qualified, so we'll just copy and paste that. Let's try that again. And so there we go. So there was, what happened was I made a request from my browser to my Play server, and then my server made a request to jamesward.com. And there is some amount of time where I'm just waiting for jamesward.com to respond. And in that amount of time, there's actually no threads allocated to this request. So we take the threads away. They can go do whatever they want somewhere else. And then when the response comes back from jamesward.com, then I get a thread back. Then I can return the response back to the user. So this whole thing now is async and non-blocking all the way through. In this case, I'm just displaying text. I didn't set the content type there, so I'm just seeing the text for jamesward.com. Obviously, we'll be working with JSON data in most scenarios, so it'd be more useful than a bunch of HTML text. So now this thing is what we call reactive composition, where it is composing together two different parts, two different reactive requests together. So just one reactive request, and then with multiple in a chain like this is, then we get reactive composition. So we can take this to another level, and then we'll move on to the client side. But if we want to make two requests, let's say I also want to make a request out to Twitter. And let's add in here a new request. And now what I want to do is compose together the results from both of these futures and not block on either of them. And then when I get the response back from both of them, then I want to fulfill the result. So the really kind of sexy way to do this in Scala is with the for comprehension. And so what I'm going to do is I'm going to say, get me the JW response out of the JW future. And then get me the Twitter response out of the Twitter future. And then when we have both of those, then yield OK. And then let's take the Twitter body plus the JW body. OK, so we're just going to append them together. Obviously, totally not practical in the real world. But there we go. So now I make the request. So there's a request from my browser to Play. Then Play makes a request to jamesward.com, makes a request to Twitter. When both of those have come back, then we fulfill the response back to the user. And there's twitter.com. And then somewhere down here is going to be jamesward.com. So we've just concatenated those together. So this whole thing now, we have 3 requests. This whole thing now is async and non-blocking. So there's some point in time where I'm waiting for Twitter to respond, or I'm waiting for jamesward.com to respond, or I'm waiting for both of them to respond. And there's no blocking on any of this stuff. I'm returning a future back to Play. And so when those inner futures finish, then I fulfill the outer future as well. So the for comprehension is a really kind of sexy way to do this. There's like 10 other ways to do this in Scala. You can zip it. You can do the expansion of the for comprehension, which is flat map and map. And there's a bunch of other ways to do this as well. So questions about that? Yeah?
Since this was a problem I had earlier this week, how do you do that with an arbitrary number of requests?
Yeah, so you can do a future.sequence. In a future.sequence, you pass it a list of futures, and then that creates a wrapper future, single future, around all those futures. And then when all of the futures complete, then you get a list of all of your results from all those futures. So future.sequence, one way to do it, but there are others as well. So, yeah?
What client library does Play use for its HTTP?
Yeah, so under the covers, we use Ning underneath it all, and that's based on Java, NIO, and Netty. We will probably in the future change this to Spray's HTTP library, but for now, it's based on Ning. Yeah. Other questions about reactive composition and how that works? OK, so we've got the basics of async and non-blocking. Now let's go on to how we hook this all up to the client side. Before we do that, I'm going to add another controller method here that's a little more useful for displaying some interesting data. So very similar to what we've seen before, I have a new controller method. This one's going to take a parameter, which is the query string, or a query of type string. And I'm going to use my little Twitter search proxy service to make requests to Twitter, search requests to Twitter. The reason why I have a proxy is because Twitter doesn't let you hit their JSON API without an API key, and I don't want to go through the rigmarole of setting up an API key right now. So I set up a little proxy that does that for me. OK, and so then let's import this thing. So what I'm doing is when I get this response back from searching Twitter, I'm going to return a response, and I'm assembling all of the tweets that I've just found in the search into a JSON array. So this is accessing the JSON. It's finding all of the text elements in that JSON structure. So that's the property name that Twitter returns in its JSON to actually get to the tweet. And then I'm doing a distinct on this because when I get into the Angular side, the way that I was doing things in Angular, it required each of these elements to be unique. So that's my easy way to do that. So there's my controller method. Let's add a route for this. So let's call it tweets. And this will be tweets. And Q is the query string parameter that we're going to pass through. So let's go test it out here. Let's go to tweets, !Q equals reactive. Let's see. So there we go. Now we see my JSON array with a bunch of recent tweets mentioning reactive. So there's my Twitter search service, and still async and non-blocking, obviously. OK, so that's my JSON service that I'm going to be working with. So now let's go on to the client side of this thing with Angular. So there's going to be a little bit of setup to set up Angular. I'm going to use Angular. Angular, it's really becoming the de facto standard for client-side JavaScript frameworks now. So if you're looking at the different JavaScript frameworks, just go with Angular. It's 6 months from now, you're going to regret it, but you don't have a better choice because there's a new JavaScript framework every 6 months that's the new hot thing. So go with Angular if you're deciding now. And so that's what we're going to do tonight. So I'm going to pull in a few dependencies here into my build. Looks like I already have most of these. I'm not going to use require.js tonight. Angular and require.js really don't work very well together. You can make them work together, but Angular is really not intended to asynchronously load things. There are some hacky and crazy ways to do it. If you really need it, go find those ways. But the two just really are not real compatible. I've heard that, and I don't need these two duplicated. I've heard that in Angular 3 or 2, whatever the next major version of Angular is, that they're going to try to address this, but that's a ways away. So we're not going to do the require.js stuff tonight. If you want to watch the video on how you can do require.js concatenation and minification, then watch the video from last night. OK, so we've got our dependency on Bootstrap and on Angular. So we're going to be using Bootstrap for the CSS and Angular for the kind of MVC part of this application. WebJars are client-side JavaScript and CSS libraries in jar files and on Maven Central, so that you can easily specify those and get the transitive dependencies and that kind of good stuff. So we're going to set up now our page to pull in these pieces. So let's go to here, and let's go. Looks like I already have some of this, but we'll just override it. So I'm going to pull in the Bootstrap CSS. The way that I do that with WebJars is I've set up a route, so now I'm using reverse routing. That's where I'm doing routes.webjar_assets. I didn't mention reverse routing, but real quickly, reverse routing in play is that we create the forward definition of the routing in the routes file. That's this one. But play compiles a reverse routing definition as well. This provides a type-safe way to look up routes, so you don't have to hard code routes in your code, and that obviously makes it hard to refactor your code. So we compile for you this reverse routing table. So routes.webjar_assets.at, that's looking up a route to this thing. And then I'm using this WebJar_assets_locate to find the actual path to bootstrap.css, because the WebJars are intentionally structured to have version numbers and library names in them, and that makes them really easily cacheable, the client-side assets here, and easy to put on a CDN. But we don't want to clutter our code with the version numbers and that sort of stuff. So this is just a little helper library to get that path. So then I'm pulling in the Angular min.js, and then I'm going to be creating a main.js script that's going to be my main JavaScript application I'll be working with. So that's my basic boilerplate page. Now let's go create that main.js file. Any questions before I do that about the setup here with WebJars and require.js, or I'm not using require.js, with Angular and WebJars and stuff? Questions about that? Yep. Is there any, sorry, what? You can pick all sorts of different options. We actually, for Activator's UI, we use Knockout. Backbone is a more traditional one. There's Ember. There's really 100 different ones. So those either been in the Java world for a long time. You'll remember when there was an explosion of web frameworks in the Java space. The same thing is happening right now on the JavaScript side. Just tons of them, tons of new ones. Angular has a lot of momentum right now, partially because Google is investing a lot into it, and so It's getting a lot of investment, not just from Google, but also the community. Has really great components, has integration with Bootstrap. So it's definitely, it's not just a hype thing. It really is a good framework. And it's super simple, you'll see once we get into the code. Did that answer that question?
Good enough.
OK.
Yeah, another guy there presenting. They're bringing some new stuff down because they have to modularize to use data serialization rules like you talked about earlier. That's all. I'd love to see what you talk about compared to yesterday.
OK. Yeah. Yeah, modularization in Angular is really hard. To do it asynchronously. You can load everything up front, and it works really well. But to do basically lazy loading of modules in Angular is really hard. There are ways to trick it and do it, but I've run into some issues with that, so I wouldn't recommend it. OK, so we've got our basic setup here. So now let's set up our page with some Bootstrap and some Angular stuff on it. We'll go in here. So I'm not going to be using the main or the index.scala.html too much anymore. I'm just going to do it all in a single page. We don't need to really reuse this. So first up here, I have a nav element. This is going to give us our top-level navigation in Bootstrap. And then I have a div. I have another div inside that. And now I have an Angular controller called hello. And inside of this Angular controller, I have a form. And I'm setting up a submit handler on this form so that when I hit submit in the browser, it's going to call a send name function in the JavaScript code that I'll write in a second. Then this form has a label, a input for the name, and then a button. And then I also have in here a UL and a list item where I'm going to tell it to repeat for all the tweets this list item and then just display the tweet. So this is data binding in Angular. So what I'm doing is I'm binding the actual tweet here to the contents of the list item. So that's the HTML side of our simple little UI. Any questions? This will probably make more sense once we see the JavaScript side of this. But any questions so far about this? OK. So let's go. I'm going to just copy and paste the next part of this here. So this is our Angular JavaScript code that we're going to be using. And so what I'm doing is I'm creating a new Angular module called MyApp, and I'm not importing any external modules. You can import like the Angular routes module or the Angular animate module or other third-party modules here, but in this case, I'm not using any of them. And then I'm setting up a controller. My controller name is hello. That corresponds with my ng controller there. And then I have a function that's going to actually set up this component for me. And so this function can take a bunch of different parameters. And in this case, I'm taking a scope parameter, an HTTP parameter, and a timeout parameter. And I'll show you why. But the syntax is a little funky with the dollar signs. I'm not sure why in JavaScript world they chose the dollar signs, but that's the syntax. So then now on this scope one, the reason why I'm using the scope one is because now these things get scoped to that component. So this now has a component model that I can use with events and with state and binding. So I'm setting up here my message value is just going to be empty at first. So that binds into this message. Oh, I'm not actually using that yet. We'll use that part later. Then I have my send name function, and this is what's bound to hitting submit in this form. So that's the function that actually gets called when I hit submit in this form. Then when we hit submit, what we're going to do is we're going to use the HTTP part of Angular, which is just a wrapper around XML HTTP request. And now I'm going to make an HTTP request. It's going to be a GET request. The URL is going to be /tweets. And then the parameters are going to be the Q is my parameter name. And then the parameter value is my scope and then your name. And if you look back here, you'll see that I'm telling it through this ng model declaration that that's the name of this input form. And so that's how I pull the value out of that form and can pass that there. And then success is the callback function for when we get the successful response back. We could also set up error handlers and that. And then what I'm going to do is I'm going to set the scope, that's this component, I'm going to set its tweets to the data that I got back, which is just an array of tweets. If we look back here, those are bound here in the ng repeat and should show up in the list items. So now this is all built on top of that async and non-blocking controller that we created earlier. It's going to make a request to that. So let's go try it out and see if our little app works. So one of the, Angular min, I need to restart because I added some dependencies. I wish we'd automatically do that. Something we want to work on. But we'll have to restart to get those dependencies. So the error was saying, I couldn't find angular min.js, which you told me to look for. And it couldn't find it because it's looking for it in the class path, and we don't have it in the class path until we reload that SBT process. So there we go. We see my page, and I'm not sure why we have all that weird space at the top. But oh well. Oh, you know what it probably is? I think I'm using an older version of Bootstrap. But OK. So so now we have our form, and for some reason it is not working. This should be bound. Oh, forgot one piece. We need to tell this thing that it is an Angular app in order for this whole thing to work. And I need to use my cheat sheet to find out what that thing looks like. Forgot that in my documentation. So there's the magic right there. Make sure I didn't forget anything else. So this is how we tell this whole thing to start working. So now let's reload this and try again. There we go. OK, looks like it's going to work now. OK, so we've got my form, and it's asking for a name. And let's just go put in a name like Reactive and hit send. That should make a request out to that Twitter service that's async and non-blocking. And then when it returns a response, then we get back the tweets. Something good in there? So there we go. And obviously, if we make another search, then it should go refresh that. So the cycle is we can pull up the network inspector here and see what's going on. So when I make a request, that makes an AJAX request to my tweets service. And then the response comes back with the JSON array of the tweets that it found from that Twitter search service. And then that is just updating my variable in my scope. It's updating the scope tweets. And then the binding is kicking in and using that to iterate through, create the list item elements with all the tweets. OK. So this is now async and non-blocking all the way through from the client side all the way back to the backend service, which is Twitter. So questions about all that stuff before we go on? Cool. Yeah.
Any specific issues about Twitter and how they implement Scala and the way you're using it here that actually that you have to customize for?
So Twitter, they do use Scala. They use Finagle. They are all async and non-blocking. That's the only way that they can scale. And so when I hit their services internally are all async and non-blocking. That doesn't impact me at all because no matter what, my web service client library is going to be async and non-blocking to them. And how they decide to handle threads is totally up to them. In Twitter's case in particular, they are async and non-blocking and reactive. But totally, that's on their side. From my side as a client to their service, I'm going to be reactive at least that far. Yeah. OK, other questions about this? All right. So that is reactive request and reactive composition. Now let's go on to the next piece where we get two-way. So before we do that, we have to talk about actors. OK. Right now, my controller code here, it is just based on futures. And we have another model for concurrency in the TypeSafe platform called Akka. And Akka is another way to manage this concurrency. And so we can use an actor model. And the benefits of using an actor model are, one, we get timeouts built into it. Two, we can go across a cluster. We can distribute these jobs across a whole cluster. And then we also have a supervision and resiliency model. One of the tenets of Reactive is to be resilient. And futures, we do have a way to recover from failure, but there's definitely some places where actors provide a much stronger way to be resilient than futures do in recovery on futures. It provides, with Akka persistence now, in Akka 2.3, we can even persist these messages and guarantee once delivery on those messages. So there's a lot of additional resiliency that we get when we move to actors. So I want to show you how we take this code that I've written and turn this now from a future-based implementation into an actor-based implementation. So to do that, first we have to create our actor. So let's go create a new actor here. And so this will be a new Scala class. We'll put it in the actors package, and we'll call this one the Twitter actor. And this will extend actor. Let's import that. And an actor, the only way that you interact with an actor is you send it messages, and then those messages go into a queue managed by the actor system, and then one at a time we process those messages out of the queue. And so the way that I do that is I override a receive method, R-E-C-E-I-V-E, receive. Is that right? E before I. Except after C. No, I before E, except after C. That's the rule. OK, so we have this receive method. And this receive method is now going to handle when this actor gets a message. And so what I'm going to say is that when I get a string method, so I do pattern matching on this thing, when I get a string message, then I'm going to now, let's go just copy and paste this code. So I'm going to now handle this stuff that I was doing before. We'll paste all that in there. So we're going to make our request to the Twitter search service. Let's rename that to Q so that works. And then let's assign this to our future response. OK. So when I get a response back from this Twitter search service, I don't want to put my results in here. I just want this to be the JS array. So what I'm going to actually return is just the JSON array of data back from Twitter. So, but I've sent this message to this actor. And really what I want for this web controller to get, I want it to be able to send a message, but then I want to get an answer back. And so there's syntax in, you can do this by sending a message to your sender. So in an actor, we always have a reference to the sender, the person who sent us the message. So I can just send a message back to them. But there's a little bit of a problem in doing that, because right now I'm actually going to be getting this response back on a different thread. And so it's possible that my sender could be different. My sender reference or state that I'm closing over could be different. And so the way to deal with this is Akka has a pattern for handling this. It's called pipe. And so we're going to import the Akka pattern.pipe. And then I'm going to say, with my future, I'm going to now pipe this to the sender. So now this says it's a way to send this message, which is my JSON array. It's a way to send that to my sender, but do it in a way that's going to be thread safe. So that's a pattern we have to use when we're in this async world inside of an actor. OK, so we've got the actor. That all looks pretty good. I'm probably going to have to import some execution context and stuff, but we'll get to that in a second. So now my controller, when we make a request to this service, I now want to send a message to this actor and have the actor give me a response back. So to do that, first I need to create the actor. So let's create our actor ref. In Akka, we never work with actors directly. We always work with references to the actors. Part of the reason is that the actor can be restarted out from underneath me. That's the resiliency model in Akka, is that this actor can go away and then come back through a restart. And so we don't work with the actual instance because that instance could die. So that's one reason. Another reason is location transparency. So this actor could actually be somewhere else on the cluster, and I want to have one way to interact with the actor. So I work with it through a reference, and the way that I create this reference is I'm going to go to the actor system in play. Let's import that. So let's go to the actor system, and I'm going to tell it, create me an actor of, and use props. And then props is the way that we can create, we tell Akka how to create an instance of an actor. So I'm going to do a props of my Twitter actor. There we go. So this tells Akka how to create this, where to create this, what class to use to create this instance of this actor that's underneath all this. But what I get back is a reference. If we look at actor of, what it provides back to me is an actor ref. OK, so I've got my actor ref. So now when this request comes in, I'm creating a new actor ref. And now I want to send it a message. But I don't just want to send it a message. I want to send it a message and get a response back. So there's a pattern in Akka to do this. We have to come import it. It's Akka pattern, and then ask is the pattern. So instead of just a tell is a send, and then an ask is a tell, and then a kind of wait for response. So I'm going to now tell my actor ref. I'm going to say question mark. That's the function to do an ask. So I'm going to say send it Q. OK? So now what I get back from doing this is not the actual thing, because we want to be reactive. We want to be async and non-blocking. So I don't get back the actual result. I'm going to get back a future of whatever this thing wants to send me back. So let's just assign that to some value here. So that's going to be my future. If we look at future, it is a future of any. So I'm getting back a future of any because Akka can send any message type. We don't know what it is. And so we're going to get back a future of any. So now I'm going to take that future of any, and I'm going to map on that future of any. And I'm going to say, if this thing is a JS array, we'll assign it to J and JS array. So if this thing is a JS array, then return OK, and then just return in the body of that OK that J. Okay? So when we get back a response from the actor, if it is a JS array, we're going to return it. There's obviously other ways that we could do that as well, but that's kind of the easy one. So now this f.map is going to return a future of a result. Okay? So let's go try it out. We are going to need some imports here for some implicits. So let's see. First, in our actor, we need to import the play app. So let's go do that. And then we're probably going to need an execution context. I'm so glad I can just copy and paste that whole thing there. And then one other implicit. So this is where the timeouts come into. An actor has an ask against an actor has a timeout that I need to specify. And so we can specify this as an implicit parameter. So let's come in here and to my controller. And I do need to specify a timeout. Obviously, through implicit resolution, I could specify it at lots of different levels. But let's specify it here for the whole object. So timeout, and this needs to be implicit. And this is going to be a duration of 5 seconds. Give that thing plenty of time to resolve. And that should work, right? Oh, no, timeout. Timeout, not a duration. Why do we have a timeout and a duration? I think it's because a timeout is finite and a duration is not, or doesn't have to be finite. OK. So let's try this again. I think I'm still missing one implicit. Maybe, maybe not. We will see. Looks like it's compiling. No, it worked. OK, cool. OK, so now we've moved this logic into an actor. We're going to get better resiliency. We could move it around on a cluster. All sorts of good reasons to put it into an actor. But it should work now the same way. Let's give it a try. Yep, and it looks like it did. The other thing that I haven't showed yet, but we could certainly do, is I could add timeout or failure handling on this future so that we could have a case that we return some logical error if there is a timeout in not getting a response back in a timely manner from that actor. OK, so now we have actor-based reactive controllers. There's one problem with this code, which I'm not going to go into, but I should probably actually shut down this actor in this case, because on every request I'm creating a new actor, and I can have millions of actors on the system. They don't use any resources when they're not processing a message, but they are going to eventually chew through my heap, and so I should, at the end of this, shut it down, or I should have a different mechanism for how I create these actors. I could have pools. There's different routing mechanisms in Akka. I can set up basically a router actor, and that can route to a pool, and it can use round robin, and it can use smallest mailbox, and all sorts of different things. So there's lots of different ways to control the life cycle of these actors, how long they're around, the routing of the messages, all that kind of stuff. But this is the wrong way to do it, because I'm not shutting down this actor, and eventually I'm going to run out of memory. So that's the actor. So questions about the actor-based controller? OK, all making sense. Good. OK, so now let's go on to, we've got our request handling with actors. Let's go on to two-way reactive with WebSockets. So it's great that now we've done this request response in and out, but let's do something more exciting where now we have a bidirectional reactive channel. So we have a reactive channel to push from the client to the server, and we have a reactive channel to push from the server down to the client. So we're going to use WebSockets for this. You could use things other than WebSockets if you want. I'm going to use WebSockets. So first, let me build out the client side of this app. Just a little bit of HTML here. So I'm going to put in here a new binding for a message that we're going to get. And then I'm also going to put into my controller a little bit of extra code that we'll walk through. So that's in main.js. And so what I'm doing is, for this controller, I'm creating a new WebSocket connection. In this case, I'm hard coding this URL. There is a reverse routing table for JavaScript in play where we don't have to hard code these routes. That's the recommended way to do it, but this is the easy way to do it. And now, when I get a message on this WebSocket, I'm have a function that's going to handle this message. And this is a kind of tricky part about Angular, but because this is async, because this message is happening async, I may have lost my context, my scope context. And so the way to handle that is you put this into a timeout. I'm not sure why it's called a timeout, but you put this into a timeout block. And then we're going to assign our scope message to the message that we received from the WebSocket. And we're going to prepend hello in front of that. OK, and then let's do one other thing here. So when the user hits that button in the browser, I'm going to send a message to the WebSocket. So I'm going to send a message up the WebSocket, and it's just going to send the name that they put into the form. This is still very request responsive, but hopefully you'll see how this could obviously be used for not just request response type of stuff, but really simple example here. OK, so that's our client side. Questions about that? Questions about the Angular side of this, the client side? I don't know. Does anybody know why that's in a timeout? I don't know how the timeout gets us into the right scope for this controller. It's something funky about Angular that I don't understand yet. Yeah, I don't know why. No, that timeout's outside of the WebSocket. So it's anything that I do asynchronously in Angular. To get the right scope, I need to put in that timeout callback. I have no idea why. OK, so now let's do the server side of this. There is a way to do the server side of the WebSocket with iteratives, and that's the default Scala API today in play for working with WebSockets. It's really simple. You can see the code there. But there's a new way to do it in Play 2.3, and that's what I want to show you because it's pretty cool. I'm pretty excited about this. So let's just go create a new WebSocket handler in Play. So first, let's create a new route. So we'll do a get handler for /echo-ws. And then this is going to go to controllers.application.echo-ws. And now let's go put that method in here. Import a few things. And and then we're going to have to create an actor. OK, so there's this new API in Play 2.3 where instead of using iterators, we can just use actors. And a lot of times when I built WebSocket apps in Play before, I was basically just delegating from the iterators to an actor. And so this is really just a convenience for how to do that. So in this case, I'm just going to be passing strings back and forth. So I'm going to get strings in and strings out. And then I've got nested callbacks here to get the request and the out channel. And the out channel, I'm going to give to this actor. So what I return in this function is the props, the thing that will create this actor. And I'm doing it this way because I need to specify, I need to give this WebSocket a handle to the out connection so that it has a handle to push data down to the client. OK. And this out channel, I should mention, is an actor. So this wraps the typical, it is the enumerator in Play. This is an actor wrapper around the enumerator that's underneath the covers in Play. OK, so now let's go create our new actor here. So we'll create the echo actor. And I'm just going to copy and paste this code. OK, so I've got an echo actor. Let's import a few things here. Don't need that. OK, so there's my echo actor. You'll see that it takes a parameter, which is our actor that we can send messages out through. And then when this actor gets a string, so it's going to, every time a message comes from the client to the server, it's going to send a message to this actor. And so when in that message, because I parameterized it here as a string, it's going to be a string message. Of course, I could be using JSON or whatever else I want for this as well. So then when I get a message, all I'm going to do is I'm going to turn around and I'm going to send this string that I just got out to the out actor, which is tied to sending through the WebSocket from the server down to the client. So that's my server-side implementation of the actor for this WebSocket. Questions about the server side before we try it out and see if it works? OK. So we've got our echo actor. We've got our client side. Let's just go take another look at our client side. So our client side, when we hit this send button, when we submit this form, it's going to call send name. We're using binding here to display a message property. And in main.js, you'll see that I am, first of all, when the user hits send, I'm sending through the WebSocket the name that I put into the form up to the WebSocket. And then I have an onMessage handler that updates the message property, which is going to update the binding and display it. OK, so let's go try it out and see if it works here. So test, and there you'll see that it updated now the binding. So I sent the message up through the WebSocket. That turned around, sent it back down to me, and triggered it. So this is now two reactive push channels. They're both push channels, just in different directions. So one from client to server, one from server down to the client. And if we want to prove that this actually is not any kind of smoke and mirrors, let's pull up the network inspector here. And we can see, let's go send a message. And if we go to frames, we'll see here's the message. I think this is the message up, and this is the message down. So we see those are the messages that got sent up and down. So that's actually going over the WebSocket. So now, obviously, this is a trivial example, request response style. But now that I have this actor on my system, that all I have to do is send it messages, and it can serialize those, send those down to the client. Now I could do all sorts of out-of-request response cycle types of things through this. So that's the basics of the WebSocket and doing reactive with the WebSocket and an actor. I could also show the enumerator more if people want to see that. But yeah, so questions about how that one works? OK, we need some more beer. Liven up the place. It's Friday night. OK, I think, let's see. Yeah, so that's really all I had. We can do some general Q&A and then go celebrate Alexi's birthday somewhere. So yeah, do you have any questions? Yeah, go ahead.
So this is all the way through. Yesterday, what were some of the points that you were in the middle of yesterday that kind of tied into this?
Yeah, oh, I didn't show the SBT-Web part of this. So the only thing I'm really using from SBT-Web here is that there's now in SBT-Web this cool linting tool. So we run JS hint automatically. So you'll see I did a typo in my JavaScript. And now just like I would normally see server-side compile errors, I see those compile errors, or in this case linting errors, right in my browser. So this is using something called SBT-JS hint. If we look in my project and then plugins.sbt, we'll see here is all I'm doing is adding that plugin there, and now it's automatically applying that linting to all of the JavaScript in my project. So that's that one. There's a bunch more that I covered last night. There's a required JS one that does the concatenation and minification. There's a CoffeeScript one, which compiles CoffeeScript. There's less, which compiles less into CSS. There's a digest one, which creates digest MD5 and optionally SHA-1 digest files that contain those signatures in them so that we can do better asset caching. There's a gzip one. Create gzip versions of all of our static assets. And then SBT Mocha is a new JavaScript testing plugin for SBT so that we can actually write JavaScript tests as part of our Play application. Those JavaScript tests run when you run activator test. So it's now built into the test cycle of SBT. So those are the current new SBT Web plugins, and the whole architecture is new and a whole lot better. In a nutshell, what we do is we actually run the native, essentially, compilers, which are all written in JavaScript. All these compilers, the CoffeeScript, the less ones, all those are written in JavaScript. We run those, and they're all written against the Node.js API. So we run those either on the JVM through an implementation of Node on the JVM called Trireme, or if you want to, you can also run them through the native Node executables as well. So now we have, we make sure that the asset compilers work the same way in Play as they would if you're using Grunt or some other tool. So that's the short synopsis of what I talked about last night in SBT-Web. Yeah, go ahead.
Optimizes for throughput as opposed to latency. Is there anything that actually kind of, guarantees a little bit of latency so that, if you have, you're just getting slammed with throughput, you don't just keep pushing off these requests?
Yeah, good question. So there's all sorts of different parameters and different types of execution contexts that you can use. The default execution context is fork join, and it has some different parameters. It's like your number of CPUs plus 1 or something like that. And so you can tweak those. You can also use, if you want to be able to get better throughput, there's a different execution context you can use, not fork join, but I forget the name of it. If you look for some Akka performance tests where they're looking for like just raw message throughput performance, what they'll do is they'll switch from fork join to a different one, and then there's a way where you can actually tell the execution context to execute like 200 operations on a single thread before it uses another thread. And so there's all sorts of different knobs you can turn to tweak your throughput, if that's what you want to optimize for. But because we have this concept of an execution context, we have this abstraction over how the threads are actually used, how many threads are in the thread pool, what the thread pool is actually using underneath the covers, all that sort of stuff. So does that help with that question, Phil? Yeah. OK. Yeah.
Along those similar lines, is there any facility or pattern that you would use to implement sort of like back pressure so that if your actor's hooking up to a service and the service is like, I'm overloaded? Yeah,
good question. We're working on something that will address that with Actor specifically. Maybe there's something in open source already for this, but we are working on something there. The iteratees, when you're down in Play iteratee land, there already is back pressure there. So iteratees definitely have back pressure built into them. One of the typical places where this gets used in Play specifically is if you have a file upload coming in to your server, and then you're taking those bytes and you're shoving them off to S3, you can actually put back pressure on the upload if S3 can't keep up with you, so you're not building up big buffers in Play. So that's we call that like two-way reactive or wait, no, yeah, two-way reactive, I think is what we were calling that. So that's where I hook two reactive channels together and can apply the back pressure all the way through that. So yeah, so that's built into iterators. There may be something already for actors out there, I'm not sure, but we are working on something for actors. Yeah?
Within the play guts, how many pool of threads, like between the handling of the request and the actual calling control?
Good question. Yeah. So we, before like play 221, I think it was really bad. Like a single request would hit like 30 different threads. It was horrible. So we now have that down to 2. So we're doing trampolining on the iterators, and the trampolining on the iterators was fantastic work that Rich Doherty did on the play team, and that trampolining was able to significantly reduce the number of threads that we're hitting, and obviously get much better performance because we're avoiding all those context switches. So 2 is probably as low as we can get, but because of how we're hooking Netty to play. Maybe we could get it down to 1 when we switch over to spray as the underpinnings there. But for now, we're at 2, so it's pretty good.
As for is there any tool you recommend to monitor? Like if I want to see a bottleneck?
Yeah, yes. It's not exactly catered to this, but I use YourKit, which I thought I had installed, but I thought that's what it was. Where is that thing? Oh, Visual VM. Sorry, not UKit. You can use UKit, but I've used Visual VM, and we could actually go in and see my, not IntelliJ. Let's open up this one. We can actually go see the threads and stuff that are going on here. So this is a great tool, Visual VM. Comes with the JDK, but then YourKit, I always forget which one it is also a great tool. There is some production monitoring support for Play and Akka. AppDynamics has Play and Akka support. New Relic just has Play support right now, and we're working with them to improve that so you can get this kind of information in a production system. So these are the best tools, YourKit and Visual VM for kind of mostly local development testing, but production monitoring, we're working with partners to make those better. Yeah. Is there a question over here? Yeah, go ahead.
What's sort of the point of using actors versus iterators and iterators? Because it seemed like it was more code, it was more complex, and we lose some of the type safety. So. Yeah, definitely. That's one of the downsides of actors is you lose some type safety. You should use whichever API works best for you. One of the benefits of using actors is that now when I'm in a clustered environment, now I have a way to communicate across those things. So a very typical example of this is, let's say I have a chat room and I've got 2 servers, and one user is connected through one server, the other user is connected through the other server, and I need to send messages to both of those. I'm going to have some way to broadcast a message to the actors on each of those nodes, because those actors are what's going to, there would be really no way to do this outside of a message bus with iterators. But with actors, now I have a model where I have an actor for each of those users, and then if I want to broadcast messages to them, I can send, through Akka clustering, I can send messages. There's a broadcast message in Akka clustering, so I can broadcast a message to the cluster, then both of those actors could receive that message and then send that down through their channels. So that's one of the primary places where it makes sense. But if that's not a use case that you need, then you may not need, in this case, you may not need actors. So yeah, good question. Cool, any other questions before we wrap up? All right, where are we going for drinks?
Let's ask the locals.
Okay, who are the locals? Not me. Where should we go for drinks? Anyone? It's Alexi's birthday, so we got to live it up.
Beer or liquor?
Beer.
Beer.
Yeah. Well, if you want to go out for drinks, find us. We'll all be going out. Yeah, thank you. Thanks. Cool. Thanks for coming.